And welcome to Desk Ladyada.
Hello, everybody. It's time for another Desk Ladyada. It's me, Ladyada, here at home. Quarantine, staying safe, staying indoors, not going outside and getting sick and endangering others. Instead, working on hardware, because that's more fun. So we're streaming on a couple different services. We got the Instagram Live, we've got Facebook and YouTube and all that good stuff.
That's right. I should mention that we do go to the factory every day, but when we do go, we're safe. Gloves, mask, all of our team has PPE.
Yeah.
We follow a very strict protocol. We're 30-something days in. So far, no one's gotten sick. No one's gotten ill. Although, testing is still not on the way. So we're just assuming that everyone has something and we have something. So let's just be smart. But tonight, we're home. So here is a desk of Ladyada.
That's right. So what we're doing tonight is I was just testing out Brent's new pull request to add FONA support to CircuitPython. What does that mean? That means that for our microcontroller boards that run Python, or even single board computers that run Python, you want to connect to cellular modems, send data to and from the internet using this cellular network instead of Wi-Fi or Ethernet. We now have the basics of support, so we're slowly but surely getting there. First PR just merged today, so people can check it out. We haven't added requests or MQTT support yet, but that's coming in the next week or two. But if people are just like, wow, I wish I had raw sockets and I would just connect to things and transfer data, you can get started right now. I thought I'd show off a little demo with the wiring of my SIM808 cellular module and Itsy Bitsy M4. So this is my little SAMD51 board. So cute, running CircuitPython. Have it wired up here to a STEMMA QT enabled OLED display. This is a recent upgrade. Our OLEDs have been like this for quite a bit, but did not have a dual STEMMA QT connector. Now they do, so it's very easy to wire this up. And then I have a SIM808 module. I like the SIMCOM modules. These are cellular modules that have voice, SMS, as well as GPRS data. They're 2G, but they still work, and they'll probably work for another year or so. Especially here in New York, there's lots of machine-to-machine that uses it. And all these cellular modules, they're actually all kind of the same. They tend to use, MediaTek chipsets or Intel chipsets or something like that. And they have an AT command set. And it's kind of, I personally am not a fan of the AT command set. I think UART-based communication is just a problem. But that's the standard, so we're going to stick with it.
Does this have SMS support?
We haven't had added SMS or voice support to CircuitPython. The module has support, and Arduino you can use it, but we haven't gotten to that yet. We're starting with data transfer because we think that's kind of what a lot of people want to do with Python. And again,
what do you think we're gonna have it?
Oh yeah, we'll have it.
Okay, there you go. That's actually what people want to know.
It's maybe in a couple weeks because we want to get the data stuff.
Yeah, the hardware can do it. We're gonna get there.
Yeah. The reason why I think data is a little bit more useful is there's the NB-IoT modules and a lot of modules that have data, but getting modules that have voice is actually starting to get a little tougher. I'm noticing that modules, if they can kind of not include voice and SMS, they kind of don't, and they just sort of do GPRS. So this is an older module, but it works fine. So let's go check out the GitHub repo. Yay, on my computer. So this is where you can find it, Adafruit CircuitPython FONA. The reason we call it FONA and not SIM808 or SIM800 or uBlocks, whatever, is again, we want to be generic. It should be for any cellular modules. And Phil and I went out for some delicious Chinese food a few years ago, and he came up with FONA as the brand name, and I'm sticking to it.
Yeah, FONA is the name for our phone products. Bluefruit is the name for our Bluetooth products. And that makes it easy for us to continue to evolve as chips change and not get stuck with, 7050909.
Yeah.
A.
And this actually kind of came with why do you call WS2812s NeoPixels? And the reason is because the actual underlying chip number changes. So it's
Huzzah is going to be an ESP32S2 soon.
I know. So it's we like to have things where it's not. I've found that if you're very specific to the part number, you get kind of burnt a little bit later on because the part number changes. Anyways, okay, so check this out. It's not quite in the bundle yet, but you can check out the library. You can, of course, just download the raw Python code. And it's a lot of AT parsing, which, on one hand is something that Python does really well. I mean, UARTs and string parsing, that's something that Python has good skills at. If you want to split a string up by commas, which is like a super common thing you have to do with AT commands, because your responses come back in like a comma-separated list with like an AT thing at the beginning. You got regular expressions, you've got string split, starts with, contains, all that, and the garbage collection takes care of your strings for you. So that's nice. After you're done, you just you leave and everything gets cleaned up and you just have your data. So let's check out the demo. And I got the demo in Moo. And for this demo, I don't know that we have SSL working yet. These modules do have SSL, but I don't know if it's like TLS 1.2. I think it's 1.1. So we're just going to use an open API that doesn't require any logins, any SSL, called the Astros Open Notify API. And when you connect to this API, you can get a JSON chunk of data that tells you how many people are in space and what are their names. Super simple, but boy, that's handy when you're like, I'm stuck here on Earth, but what if I want to know who's in space? So we're going to try to make this as similar as possible to the way we did Wi-Fi and the way we did Ethernet. So in CircuitPython, we decided, it's actually a little tricky because Python, like CPython on a computer, it uses the operating system's network stack. Through Python, you don't have to set the Wi-Fi password. Through Python, you don't have to check your Ethernet. It's like the network is handled by the operating system, and you use sockets and you connect and you do stuff in DNS and everything's wonderful. With microcontrollers, you're not that lucky, and especially if you're doing something with cellular where it's like, well, you have to do all these commands to get and send data. So we try to mimic a socket interface. The socket interface, like the BSD socket API that CPython has, we basically mimic it. So instead of having import socket, we have import Fona_socket. And then, the API is socket-like, and then underneath it kind of does the actual data transmission and opening the socket and reading the data and writing the data, checking how many bytes are available, and closing it. Only thing that's a little different is when you're dealing with SSL, this kind of all breaks down, especially when the modules have native SSL support, because again, it doesn't mimic CPython as closely as we'd like, but it's good enough. And then at higher levels, like at the requests library or the MQTT library, it's totally fine. But it's at these lower levels, it gets a little bit murky. So we create the UART, we have a reset pin, we create the Fona module, and then we bring up the GPRS connection, that's the data connection. It takes a couple seconds. It's not fast to make the connection. That first connecting to the cellular network, connecting to GPRS, it actually does take 15-20 seconds. And then here's the weird magic we do. We have an object like the socket object that normally you would just say socket to get a new socket. In this case, you set the interface. So this is a non-CPython function and argument where we tell it, okay, we're going to use the cellular object, use that to do your internet connectivity. So I'm actually going to restart this, and so you can actually start seeing the AT commands down here. I have the debug on. So you see everything is done by AT commands. So for example, you want to connect to GPRS, AT plus CREG, question mark, that'll tell you whether you're connected. And then once, we are connected to the network, which is going to take a while, we can open up a socket. Well, first off, we have to authenticate and stuff. Then we can open up a socket, connect to the socket. I don't think we have to do a DNS lookup. I think it's smart enough that you can open a socket to a domain name. Sometimes this network is unhappy. You want to connect? Okay, looks like it connected. It authenticates. This password and username is not real. That we don't actually have password protection. You should put anything in. And then finally, we can get to allocating a socket, creating a socket, and then opening the TCP connection. You see, to open a socket, you literally call like SIP start TCP, your domain name, and 80. And of course, it didn't work. I'm going to start again. And then with SSL, I think you can do like TCP underscore SSL or something to connect to the socket. But if this did work, which maybe it will eventually, you connect to this API, you get the JSON data, you parse the JSON data, and you get out the number of astronauts and their names. And this is one of the nice things about, again, Python, which I like. Doing JSON decoding in Arduino or C or C++ like really kind of sucks. Now, underneath the Python, yes, it is done in C, the low-level stuff. But when you get the data, it's in this nice structure that you can use. Okay, so let this keep trying to connect. And I'll go over here. If you want to pick up a SIM808 shield, you plug it into your Metro or whatnot. If you want to test this out, you can pick them up with DigiKey. DigiKey is selling our shields and goodies while we are deemed an essential service and not shipping out some stuff.
Yes, you can get them from any of our resellers. However, DigiKey is partnering with us for all sorts of things. Thank you, DigiKey. Please shout out to DigiKey on Twitter and in the comments. They like to see that this is working out, and we appreciate them and all the team members at DigiKey that has been helping us out so much here in New York City.
Okay, there you go. Oh, shield. Breakout's out of stock because we're making some this week. And then the board I'm connecting to is the Itsy Bitsy M4, which is a favorite, and they have like a lot in stock. So if you want some Itsy Bitsies, it's like a tiny 120 megahertz microcontroller for like, what do they have it for? $15. Good deal. Pick some up. All right, let's check back. Wow, it's not letting me connect.
People say you need a bigger antenna, maybe.
I know, man. No, I mean like it's connected to the internet, but then I wonder if it's because I connected so many times that it's like kicking me out. That's annoying. Hold on, let me go to. It was like, I tested it like 5 times before we went live, and then like maybe they're like, you can't connect that much. Astros. Okay, well, that's all annoying. Well, I'll try one more time, and I'll take questions while this is.
Okay. Well, I was asking them as you did it.
Yeah.
There's only 5 left on DigiKey, by the way.
These, yeah.
Yeah, folks. Greg says it's 1.1 only on the phone board.
Yeah, which isn't so great. So, if we do a lot more stuff with cellular, one, we might try to figure out how we can upgrade the firmware. But the second thing you might have to do is run something like bare SSL, which is an SSL layer on the Itsy Bitsy to communicate. All right, come on, connect to this API. You can do it. Connected. Read that data. Oh no. Yeah, it's not happy. All right, well, that's how live demos go.
Yeah, you can see.
Kind of fun to watch it, streaming by on that display I/O. They'll have to believe me it was working.
Okay.
Actually, you know what I could do is I could do a hard reset.
Do a hard reset.
Okay. While I do, hold on. I'll do a hard reset.
Yeah, while you're doing that, I'll tell people about how they can support Adafruit.
Okay, and then I'll show some. It's not out yet.
Okay. So we have our manufacturing, engineering, and logistics service and R&D going. If you're a big company, organization, government, or university, or someone, just check out our site for that. We are shipping essential goods. Make sure you, on checkout, if you know what that means, components for medical devices, essential orders, and if you're essential business, you can order. And we're also doing face shields for the city. Those are not, of course, for sale. You can buy a gift certificate in Adafruit store. You can get Adafruit IO Plus. There is, I think, 20 Ada boxes
Okay, wait.
left.
I think it's connecting this time.
Oh, well, all right.
Yes! It connected. Okay, so
All
if you
right.
go to my computer. Sorry. Of course, it's like right when you're doing
No,
something.
fine. I was finished.
So something a hard reset. I think the reset pin might not actually be doing a hard reset. Also, I might request that when we have this library, it clears all your sockets. I think the socket was getting like hung. It was like trying to reuse a socket. Okay, so I connected. I did the HTTP request. I got back this chunk of data, so you can see the HTTP, 200 and the headers, and then finally this data chunk over here. So this is it parsed out. And then what I do is I just, find the JSON data, convert it into an object, and then I can read out the 3 astronauts, Chris, Cassidy, Anatoly, and Ivan. And then on the overhead, I can show the names I have printed out. Yes, it's my 3 astronauts. So first connection was a little tough to get going, but we did eventually get it going. But that's to be expected because it's like a very, very new library. And again, I really wish there wasn't AT only, but it's kind of what it is. So it's just a process of finding these little bugs and tweaking the code and knowing when to have timeouts.
Okay, is there an example of pushing data through the FONA and the Adafruit learning system to Adafruit IO?
There is for Arduino, but this CircuitPython code was just published like 10 minutes ago.
Okay. Yep, AT commands are from the 80s. That is correct.
They're terrible.
And then...
we're from the 80s, so...
Yeah, and folks want to know... They just discovered Adafruit. They want to know how we're doing. We're doing good. We're making face shields for New York City and hospitals, and we're making essential, very much needed electronics for things like ventilators and more, and medical devices. So we're... most of us are not working, but a small team of us are. And... we continue to pay everyone, all 100 plus people.
Yeah.
No layoffs, no furlough, no cut hours. All of our contractors are getting paid. Even the outside services, like our cleaning crew, because if we don't pay them, they don't have jobs. So we're doing all of that, and it is difficult. It is painful. It is scary, but it is the right thing to do, and we are doing it. And that is what companies can do. Not all will, but we are. And we'll be fine on the other side because we have cool people in our community that are going to help support us and more. So thank you everyone who tunes in and been a great customer over the years. That's why we're able to hopefully weather this storm, as they say.
Okay, cool. All right, so the next thing is I want to show some. It's just
guys,
very
not
hot.
Out yet? Oh, I don't even have the graphic for that.
Well, it's okay.
Okay,
I mean,
this is
that's
breaking news.
I
didn't even. This is news to me.
So this is.
I live here.
I got this shipment today from Espressive. Thanks to them for hooking me up. I got another Cellular because I sent mine to Scott. You saw his live stream yesterday. He's been working on trying to get the ESP32S2 up and running on CircuitPython. We got Team USB going, and so I actually got 10 of each. So this is the Waroom module. So this doesn't have PSRAM, and this is the Warover, which does. So it's actually the same footprint, which is a little bit surprising to me because usually the size of the module was dictated by the fact that it had this extra PSRAM chips. So for the ESP32 plain, the chips, the Warover was smaller. Sorry, the Waroom was smaller than the Warover on the side, but now, I don't know. I'll have to decap one of each of these to find out. But I really like this marking on the bottom. They have all the pins labeled out.
Do you want to answer questions while you're showing us on it yet? Or?
Yeah, sure.
Okay, are there CircuitPython libraries for the NRF 24L01 or CC1101?
The 24L01, somebody did write one. It's in the contributor bundle, or community bundle.
That was it.
Yep. All right, that's all I had to show.
All right.
Cellular.
Someone dropped some bucks in our YouTube channel. That's nice of you.
Thank you.
And then someone's going to buy a gift certificate on our store.
Yay.
And the cool thing about a gift certificate, it's not like you're just giving us money when we're, back to what will be called, quote, normal.
You can buy stuff.
You can use it. And it never expires. And we do not share your email address. We don't spam. We don't have pop-ups on our site. So, you want certain companies to make it through this. I think we're one of them. So it's a good value. It's a good value. And this is what Ladyada looks like. Now she has a mask when she's at the office, but
Yeah.
Yeah, this is us. This
Just a little skinnier.
We look like this, yeah. All right, so that's the
All right, thanks,
Ladyada.
everybody.
All right, bye everybody.
Bye. See you
We're
later.
gonna keep doing these.
See you later this week.
Bye bye.
More coming soon.